We have here another problem for curves of type 3. We are asked to discuss and trace the curve whose equation is y squared is equal to x multiplied by x plus 4, x plus 2, and x minus 3. What we are going to do is, of course, to determine these values, whether which part is positive and which part is negative. So for the first factor, x, then we have here x plus 4, we have x plus 2, and we have x minus 3. If we are going to multiply these four factors, this x, the x plus 4, x minus 2, and x minus 3, that would be equal to y squared. So if we are going to multiply these four, so we have here our y squared. Now, if we are going to take the square root of y squared, then we have here the value of y. So let us now determine where these values would be 0. So for this x, that would be 0 at 0. For x plus 4, so that would be 0 at x is equal to negative 4. For x plus 2, that would be 0 at x is equal to negative 2. And this x minus 3 here would be 0 at x is equal to 3. So for x, that would be 0 at 0. We are going to substitute this with the value on the right side of 0. That would give us positive result. So that would be positive on the right and negative on the left. For x plus 4, so that would be 0 on x is equal to negative 4. So that would be positive on the right and negative on the left. For x plus 2, so that would be 0 at negative 2. So that would be positive on the right side and negative on the left side. So for x minus 3, so that would be 0 at x is equal to positive 3. So that would be positive on the right side and negative on the left side. Now, in order for us to determine the value or the sign of the y squared, we are just going to multiply these four. So we have negative times negative times negative and negative, so that would be positive. So 0 multiplied by negative, that would be 0. Negative, positive, negative, negative, so that would be negative. And in here, that would be 0. So negative times negative and multiplied by positive, so that would be positive. 0 times positive, positive, negative, so that would be 0. Positive, 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 and negative, so that would be negative. And in here, that would be 0. And we have here the positive value. Now, in order for us to know the sign of the y, we are going to take the square root of these values here, as we know that since we have here the value for the y squared, so in order for us to determine the value of y, we take the square root. For the positive, we have a plus and minus, and at 0, so that would be 0. And the square root of a negative number is imaginary number. And this one is 0. So for the positive, we have the plus and minus. And for this, that would be 0. And the negative is imaginary. So this would be 0, and this would be positive and negative. Now, by looking at these values, since we can see here, these 0 here are the location of the x-intercepts. And these locations where we have the imaginary number, it means that we do not have a graph for these regions. And in here, where we have the positive, negative, so it means that we have graph both above and below our x-axis. So this is very evident since if we are going to inspect our equation, if we are going to change the value of the y into negative y, our equation will not change. So this only means that our curve is symmetrical with respect to our x-axis. While if we are going to change the value of the x into negative x, so our equation would change. So it only means that there is no symmetry with respect to the y-axis. And the same there is no symmetry with respect to the origin. So it is time for us now to trace our curve. As we can see, we have our x-intercepts at -2, and we also have our x-intercept at x is equal to -4. We have another x-intercept located at x is equal to +3. If we are going to check the location of the y-intercept, what we are going to do is to substitute the value of 0 to our x. So for this, we substitute 0 to our x. So our equation goes this way. Y squared is equal to, so 0. Since 0 multiplied by any number is 0, so that would give us y is equal to 0. So it only means that our y-intercept is located at the origin. As you can see, this is also the location of our x-intercept. So this only means that the x-intercept and the y-intercept coincides at one point, and this is our origin. Now, if we are going to check on the regions, so we have the graph for the regions between 4 and -2. We have another region from -2 to 0, so that would be at the y-axis, and another region from 0 to +3. As you can see, we have imaginary value between -2 and -4, so this only means that we do not have graph at this location. We also have an imaginary result between 0 and 3, so we do not have graph at this region. And for this, for -4 up to the -infinity, we have the positive and negative. So this is only evident since we have a symmetrical curve with respect to the x-axis. So we are expecting that beyond -4, since if we have this graph, so we also have this graph below. And this is symmetrical with respect to the x-axis. Going back here, so as we can see, we have our x-intercept at x is equal to -2 and at 0. And we have the positive and negative value in between them. So we are expecting a closed figure in here. So that would be a circle or an ellipse. So in order for us to determine whether this is a circle or ellipse, so first is to check what would be the value of y if our x is equal to -1. That would be the value between 0 and -2. So we are going to substitute -1 to our x. So we have here y squared is equal to -1. -1 plus 4, so that would be +3. And -1 plus 2, so that would be +1. -1 minus 3, that would be -4. So we have -1 times 3 times 1 times -4, so that would be +12. And this is y squared. So taking the square root of 12, so that would be square root of 12, or that is approximately 3.46. So since that is 3.46, while this 0 to the center is just 1 unit, so this would be elliptical. So 1, 2, 3, and 0.46 in here. Since this is symmetrical with respect to the x-axis, so we also have 3.46 at the bottom. For our 3, to the positive infinity, we have the positive and negative value. So we are expecting here the same graph at the bottom. Let us now discuss our curve. So let's start with our domain. For the domain, as we can see here, we have the values from the negative infinity up to 4. So that would be any value of x, such that x is an element of the set, from the negative infinity up to negative 4. So that includes 4, union of the set from negative 2 to 0. Union of the set from 3 to the positive infinity. While for our range, as we can see here, we have all the values for the positive and negative y. So this only means that any value of y, such that y is an element of real number. For the intercepts, we have for the x-intercept, we have negative 4, negative 2, 0, and positive 3. So that would be negative 4, negative 2, 0, and positive 3. While for the y-intercept, we have at 0 also. So our b is equal to 0. For the symmetry, as we can see by inspection, that we only have our symmetry on the x-axis. Whatever is our graph below, that is also our graph above the x-axis. And there is no symmetry with respect to the y-axis and the origin. So for the scope, since this is symmetrical with respect to the x-axis, both below and above our x-axis, our curve has the graph from any value of x such that x is an element of the set from the negative infinity up to negative 4, not included of course is negative 4 because that is our x-intercept, union of the set from negative 2 to 0, union of the set from 3 to the positive infinity. So for this type of curve, we don't have our asymptotes. And if we are going to talk on the discontinuity, our curve is discontinuous in this location where we have an imaginary value. So the curve does not exist at x from the negative 4 up to negative 2, union of the set from 0 to positive 3.